What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at features of a circle. We've had a look at things like squares, rectangles, triangles, but for some reason that we are going to find out, circles are a little bit more difficult. There's a specific language that we need to use when we're talking about them, and that's what this video is going to go into. So the first thing we're going to do is actually try and work out what a circle is. It's a really hard thing to define without using words like round or circular, okay? We know what it looks like, it's just a circle. But being able to define exactly what it is going to help us out in the long run. So to work out what the definition of a circle is, I want you to, in your mind, imagine riding a bike. I've got the bike wheel here with the center and all the spokes going out towards the tire. So if you imagine riding along, we know that it's going to be quite a smooth ride unless we go over something bumpy or anything like that. But let's say that I shortened one of these spokes and the tire actually came in with it. So if I moved this around and then finished off my tire, even if it was something small like that, you would be able to tell me that every single time that I went around on that part of the wheel, I would get a huge bump. So now this wouldn't be a circle anymore. So because I changed the distance of one of those spokes, I've had a circle and now I don't have a circle anymore. So that's actually something that's really, really important for our definition of a circle. The actual mathematical definition is that it's a series of points that are equal distance from the point in the center. So if we go back to our bike wheel analogy, you've got something in the middle, all the spokes that are coming off it are all an exact equal distance to the tire on the outside. And that's how we know that the bike wheel is a circle. So we're going to have a look at this on a Cartesian plane, just to make sure we know that this is definitely going to be correct. It does look a bit silly to start off, but bear with me because I know it's going to look right in a second. So on this Cartesian plane, I've got the radius of 2. So I've gone up 2 positions from my origin. And we've said that the definition of a circle is points that are exactly the same distance away from a central point. So if I add in 3 extra points that are incredibly easy, I can put one at 2, 0, minus 2, 0, and 0, minus 2. So now with these 4 points, you're thinking, well done, Johnny, you just made a square. Mad. But if I wanted to have my radius that's 2 up, if I pushed that over to the side, you could see in your mind's eye that the tip of it would kind of fall in a curved way. So if I wanted to add in points that were exactly that radius away from the origin in that first quadrant, they would have to go in a curved fashion like this. So I could start adding in all these points in this curved fashion all around the Cartesian plane as well. The more points that I add in, you can see it's starting to look more and more like a circle. So eventually I would add in so many dots, that you wouldn't even be able to see any gap in between them. So it would just look like a solid line. And that is how these points that we've been talking about relate to a solid line in the shape of a circle. So there are 3 features that we're going to focus on in this lesson about the circle that make it really important. The first thing is the distance from the center to the tire, kind of like the bike spoke that we talked about before. So this distance here from the center all the way to there in a very straight line is called the radius. We usually call it with a little r. But the important thing, because of our definition of a circle, it's equal distance, that means that this is also the exact same length. And we call that the radius as well. This is going to be the radius, this is the radius, this is the radius. All of these are the same distance because the circle definition says it has to be so. When you do see a question with a circle in it, chances are you are only going to see one radius drawn. So just make sure that you know that even though there's only one in there, there are literally infinite ways that we could draw the radius in that circle. So the second thing that's really important is kind of the size of the circle. So if we had a look at these 2 circles and I asked you, hey, which one's bigger? You would go, obviously that one. If I asked you how you knew that, one way that you could define it is say, oh, well, this one's only 2 centimeters up and this one over here is 5 centimeters up. And that would be a really good definition for why this one is bigger. But because it's a circle and it's got unlimited axes of symmetry, I could do this exact same distance in the middle. I could do it through here, through here, through here on both of these circles. So this distance from point to point through the center, that's really important. So from point to point through the center is called the diameter. And that's how we define how big a circle is. And because it goes through the center from one point on the line to the other, there are, again, infinite of these. So this one's the diameter, this one's the diameter, this one and this one are all the diameter. So you can write it in any way you want, but there is only going to be one given to you in a question. Another way to think about the diameter is it's basically the same as having two radiuses that are exact opposites of each other. So if I had this radius here, and then I had another radius on the exact opposite side that was over here, both of these would equal r. But now this looks like my definition of the diameter, point to point through the center. So another way to write this would be the total distance is the diameter. So if you just know that the diameter is equal to two radiuses or 2 times the radius, you will find this incredibly easy. Mathematically, we write it as the diameter, or d, is equal to 2r. The last thing we need to know is the distance around the circle. We've looked at the perimeter of other shapes before, and this is the exact same concept. With our bike wheel analogy, you can think about it as how much tire is there actually on this wheel. For circles, we call this the circumference. Even though it is basically the perimeter, because it's circles and they're special, we're going to give this a special name as well. So the outside of a circle is called the circumference. That distance is the circumference. Just make sure if you're talking about a square or a triangle, you use the word perimeter, not circumference. Circumference is exclusive for circles. So just on a drawing, the distance from one point all the way around to that same point is the circumference. So as long as you shade all this distance around the outside, that there is the circumference of the circle. I know we haven't gotten into much maths this lesson, but this is foundational in moving forward with this topic. I do hope you found it helpful, and I'll see you later.